So this question is related to mainly carbonyl chemistry. So naturally occurring ketone is there a compound A contribute to a smell and a flavor of some blue cheese. This is a naturally occurring compound. Give a synthetic name, a systematic name of A. So one, when we will count the carbon atom, numbering should start from nearest carbonyl group. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. So second position I have a carbonyl, but if I count from the other side, it will be at the sixth position. So second position I have a carbonyl group. So it's due to 7 carbon, it is hep. So hep due to 7 carbon, and because they have a single bond. And second position, we have a carbonyl group, so heptane 2 on. Compound B is an isomer of A with the same functional group. Describe a simple chemical test that you would use to distinguish between A and B. So they are both carbonyl groups, they are both ketones, but you can clearly see one of the ketone is having a methyl group next to carbonyl group. Like this one is having a methyl group next to carbonyl, but this does not have a methyl. Methyl means CH3. So what we can do to identify a methyl group attached to carbonyl group, we can warm with iodine and sodium hydroxide. And as a result, what we'll observe a yellow PPT. With A, it will give a yellow PPT. With B, there will be no change. So we'll add iodine with sodium hydroxide. With A, it will give a yellow PPT. And with B, there will be no change. No visible change or no reaction will be there. Because methyl group next to carbonyl groups give a positive result or iodoform reaction. Give 2 chemical tests for B, which can be used, when we used together, would confirm B contain a carbonyl, not an aldehyde. And it's like it is having a carbonyl group, but it is not an aldehyde. For each test, state the result and what is deduced. Because for B, you can see it's having a carbonyl group at the center. So what will happen? And there are 7 carbon atoms are there. So first, how to identify that there is a carbonyl group, but that carbonyl is not aldehyde. So to confirm the presence of carbonyl group, we use 2,4-dinitrophenyl hydrogen. And when we use 2,4-dinitrophenyl hydrogen, even it's an aldehyde or a ketone, it will give a positive result. It will give a yellow or orange precipitate. And second thing, we can use a Falling or Benedict solution. Because it is not an aldehyde, so it does not give, because Falling or Benedict solution will form a, because Falling or Benedict solution contain copper 2 ion. Copper 2 ion is blue in color. When aldehyde react with Falling or Benedict solution, copper 2 ion reduced to copper 1 ion, so the solution turn into red-brown PPT due to copper 1 oxide. So here, first, we can use to confirm the presence of carbonyl group, we can use 2,4-dinitrophenyl hydrogen, and it will give a yellow PPT. Then test 2, what we can do, we can use a Falling or Benedict solution. There will be no change because it cannot be oxidized, as it is a ketone, it is not an aldehyde. Then give a displayed formula or structural formula for compound which form when A is reduced. So compound A was, this was a skeletal formula 1, 2, 3, 4, 5, 6, 7, and there was a carbonyl group attached here. So when it is reduced, it will convert into alcohol, which alcohol, basically reduction means addition of hydrogen. So the double bond here break, 1 hydrogen will be attached here and 1 hydrogen will be attached here. So it will turn out to be hexane 2-ol. So we have to draw a structural formula or display. In a discrete formula, we represent all the bonds present, and in a structural formula, we can represent them in a group. So the formula, if I want to draw a displayed formula, 1, 2, 3, 4, 5, 6, and 7, and then there will be O and H will be there. H, this will have 3 hydrogens. This will have 2 hydrogen. This will have 2 hydrogen. This will have 2 hydrogen. This will have 2 hydrogen, and this will have 3 hydrogens. And reducing agent is Li. Lithium tetrahydrodualuminate will be there, which is LiAlH4 in a dry ether. Remember, don't forget to write this, dry ether. This part we have to complete the hydrogen cyanide HCN react with A in the presence of, this is A. We have to write a mechanism for this reaction. So nucleophilic addition reaction is there when this reaction proceeds. So we have this C double bonded with C, C double bonded with O, the carbonyl group is there. Carbon is having a partial positive and oxygen is having a partial negative. So what will happen? The CN group, nitrogen and carbon triple bond is there. This is having a negative charge on CN, and this will be partial positive and oxygen will be partial negative. So this will attack on the carbon and oxygen will break the bond. As a result, what will happen? So it will be N triple bonded with C. There will be a bond between carbon now. 1, 2, 3, 4, 5, 6, 7. And this oxygen will have a negative charge. Why? Because it took the electron which are involved in the bonding. It took its electron as well as electron from carbon. So there's a negative charge. Then what will happen? There will be another HCN will be there. There will be HCN will be there. So this negative will attack on the hydrogen and this carbon will break the bond. So as a result, what will happen? What it produce? There will be 1, 2, 3, 4, 5, 6, 7. And there is CN is there attached. And OH is already, because this hydrogen is taken and it produces a CN. And then this will further react with another molecule, which result in a formation of another nucleophilic addition reaction. Then the next part, by considering the reaction mechanism and explain why the solution produced does not rotate the, even though this carbon, this is a chiral carbon, but even though this chiral carbon is there, but it does not have any effect on, it is having effect on the polarized light. But the thing is, there is always a possibility that CN group, because this is a planar group, carbonyl group, whenever, even for aldehyde or a ketone, this is a planar like this, each bond angle is 120. So what can happen? The nitrile group, the CN group can attack from the left hand side. It equal possibility it can attack from the right hand side. So as a result, equal possibility is there. So it will produce two optical isomer L and D, and they will be in the same quantity. So as when we have the two isomers, optical isomer in the same quantity or ratio 1:1. So what we call that as a racemic mixture. So because carbonyl, whites of 3 marks, so you have to mention that carbonyl groups are planar. That is 1 mark. Then the cyanide group or CN group can attack from the left hand side or any side, above or below, right or left, or either side you can mention. So as a result, it will produce a racemic mixture, and that's why it does not rotate the polarized light.